Page 576, lesson 9.5 is on completing the square. So we've talked about factoring trinomials into two binomials. They are not always going to factor out perfectly like they have in the past for us. So this method is one of the ways we can deal with that. One of the ways we can find our roots without a calculator, even if the roots don't come out evenly. So in the essential understanding, it says you can solve any quadratic equation by first writing it in the form m squared equals n. And at the bottom, it talks about this process of completing the square. What we're going to do is we're going to give you some steps here to kind of break down how we're going to work this out for completing the square. So the first step for completing the square, you're going to add or subtract c, which is the constant value. Then you're going to take half of b and square it to find what I'm going to call the new c. And then we're going to add the new c to both sides of the equation. At that point, we will factor, and it'll be a perfect square. So it'll be like a binomial squared, and then we'll take the square root. When we take the square root, remember we need to add plus or minus in front of that. And then finally, we will add or subtract to get the variable term by itself. Again, a lot of these are not going to come out evenly, so they may ask you at sometimes to round your answer to the nearest tenth or nearest hundredth, something like that. And I guess we'll do step 4 after step 3, and then step 5 and 6. So if you look at problem 1, what is the value of c such that x squared minus 16x plus c is a perfect square trinomial? And so what they're pointing out here is the value of b is negative 16. And so kind of like we talked about a minute ago, if you take half of that and square it, that's going to be our c value. So half of negative 16 would be negative 8. And then if you square negative 8 times negative 8 would be a positive 64. So c equals 64 for that problem. Over to the side, they ask about can c be negative, and the answer is no, because like on this example, we had a negative number we squared, which makes it positive, or if we had a positive number and squared it, then it would be positive as well. So c is always going to be a positive, or our new c, as I'm calling it, is always going to be a positive number. So if you look at the got it 1, what is the value of c such that x squared plus 20x plus c is a perfect square trinomial? I guess going back real quick to the previous problem, if we say c equals 64, just to show you kind of where we're headed with this, or what the reasoning is for doing this, which you'll see more as we go along, but if we put that c as 64, what happens then is we can factor this as x minus 8 times x minus 8, which is the same as x minus 8 quantity squared. And the reason we're doing that, you'll see later, is because, like we mentioned at the beginning, that would put it in that form m squared equals n. You have something squared equals a number, then you can just take the square root, plus or minus, and then add or subtract, and you'll have solved for the variable. So on this problem, our b value is 20. So if you take half of that is 10. And then if you square that, would be a 100. So we would want C to equal 100 for this problem. And again, what we could do at that point, then that would give us x squared plus 20x plus 100. And then that puts it where we can actually factor it as x plus 10 quantity squared. For this right now, all we're doing though is saying C equals 100. So if we look at problem 2, now we're actually given an equation to solve. And now this is where we go through the steps that I mentioned. So the first thing, if you look at what the book did here, they had x squared minus 14x plus 16. Realistically, if that was your equation, the first thing you would try and do would be to factor it. We would try to factor it into two binomials. We know both of these have to be subtracting, and then we could try, 8 and 2. That's not enough because that's only a minus 10x. We could try 16 and 1. That's too much. That's minus 17x. So normally we might just say, well, it's not factorable. Okay, but what we're learning here in this section is there's ways around that. If it's not factorable like that, we can rig it up to make it work. So what they did here, they first subtracted 16 on both sides. Usually what I like to do is after I subtract 16, rather than writing this step, I'm going to leave a blank spot. I'm going to say plus blank on both sides. And then this is now finding that C value like we talked about a minute ago. So half of negative 14 would be negative 7. And if you square that, would be a positive 49. Or realistically, if you guys want to, you can kind of just ignore the negative sign because we're squaring it anyway, right? So half of 14 is 7. If you square it, it's 49. So add 49 on both sides. And then this factors, they didn't really show it this way, but this factors would be x minus 7 times x minus 7, which is x minus 7 quantity squared. And then if you combine these together, you get 33. That's x minus 7 squared. So what we can do next is we can take the square root on both sides. When we add the square root sign, we got to add plus or minus in front of it. And then that gives us x minus 7 equals plus or minus square root of 33. And so at that point, we can just add 7 on both sides. If you add 7, you're going to get 7 plus or minus square root of 33. And that's how I like to work this out. I like to go ahead and just say, okay, that's my answer. And if it asks for an exact answer, you can leave it like that. If they wanted a rounded answer, then we can work them out separately. So this over here, the 12 and 7400ths, that would be 7 plus the square root of 33. And then over here, this would be 7 minus the square root of 33. So this would be if they said, what are the answers to the nearest hundredth? Then we could write them out like that. And they really should specify whether they want an exact answer or if they want estimates, or maybe they want both. Maybe they want exact answer and estimates on these problems. This problem is not in your book. We're going to look at first before we continue on. What are the solutions of the equation y equals, it should just be x squared plus 12x minus 20 equals 0. So again, this would be a problem where we could try to factor this first. Okay, because realistically, if you were doing a final, on the final, they're not going to have it separated out and say, this is the completing the square section, where they're not going to factor. You're going to have to just be able to figure that out. So you could try this. Since that's negative 20, one sign's got to be positive, one has to be negative. Factors of 20, we could have 1 and 20, 2 and 10, 4 and 5. The deal is, though, since our signs are different, you might think, oh, 2 and 10, that looks good. The problem is the signs are different, so they're actually subtracting each other. So that would give us, the closest we could get there would be 8x. So that's not going to work. So this is not going to be factorable like that. And so we're going to have to go to our completing the square trick here. So completing the square, again, first thing is to add 20 on both sides. And again, what I'm going to do at that point is I know I'm going to be finding a new C value. So I'm going to put a blank there. And again, we're adding that on both sides. As long as, we have an equation where these two things are equal, if we then add the same number on both sides, we're keeping it balanced. So to find that new C value, if you look, B is 12. So if you take half of 12 is 6. And then if you square that, would be 36. So 36 is our new C value. And that's the number we need to add to both sides. The left side I'm just going to rewrite just like it is. And the right side I'm going to go ahead and add those together, which would be 56. And then now we should be ready. We've rigged this up, so there shouldn't be a question now. This should work where this factors as a binomial squared. So we know we've got x's to get the x squared. We know all the signs are positive. And we know these numbers have to be the same. So really, if you just take half of your b value, half of 12 is 6. We put that on both of them and then double check. 6 times 6 equals 36. So we should be good if we FOIL that out. So that's going to be x plus 6 quantity squared. And now we're ready to finish this off. So what we need to do next, kind of to get a little closer into the x to be able to solve what it is, we need to take the square root on both sides. That gets rid of the squared. Then the last thing to get the x by itself is they're adding 6, we subtract 6 on both sides. And again, this is showing a little bit different than what the book's doing, but I just like this better. I think this is how I learned how to do this. That gives us the exact answer altogether. And then at this point, now we can find the estimated answers. So let's act like they said they want the exact answer, and then also they want the answers to the nearest hundredth. So we have both ways. Usually when they list answers, they list the smallest number first and then the biggest number. So if you want your answers to be in the order they have them in the back of the book, stuff like that, how they'll be read off. Usually I do the negative square root part with that one first, or the subtraction, and then the addition I do second. So the first one here, if you type that in, work that out, you can actually type it all at once in your calculator. -6 minus square root of 56, and that's nearest hundredth would be -13 and 48 hundredths. And then what you can do then, you can do second equals, and it'll retype what you had typed in before, and you can just arrow over to the subtraction and make it addition, or you can just retype it. And that comes out as 1 and 48 hundredths. So these would be our two answers. approximate answers, and then again, this was our exact answer for what would make that equal to 0. So let's go ahead and look at the got it 2. The reason I looked at that other problem first is it's a little bit simpler than this one. So we'll see why in a minute. So they went solutions of this equation. Again, we can try to factor this. We could do 3 and a 5 to get 15. 3 plus 5 is 8. That'll give us 8x, not 9x. So we actually won't be able to factor it that way, so we will have to do completing the square here. So the first thing we've got to do is subtract 15 on both sides. We've got to clear out a space for our new c. And like I said, I like to put plus blank on both sides, so I make sure I remember to add that number on both sides of the equation. So our b value is 9. And this is why this problem is a little bit more involved, because if you take half of that, that comes out not evenly. What we're going to do, though, is we're going to just keep it as an improper fraction. So if you squared that, that would be like 9 times 9 over 2 times 2. So that's going to be 81/4. So I'm going to say we're adding 81/4 on both sides. So the left side, I'm just going to leave as it is. If you want to, I guess you could think about that you're going to go ahead and factor this on the next step. If you want to get that process started, you can. On the right side, so we can get a common denominator over here in order to try to combine those together. So that'd be -60/4 plus 81/4. And I'm just going to leave the left side alone for the moment. So that would be 21/4 if we combine those. And then now we'll go back over to the left side. So all we're doing is taking half of our middle term. Our middle term is 9. We're putting half of our x's on one side and half of them on the other one. So 9 halves, which is the same as 4 1/2 in each spot, gives us 9 altogether. And then that gives us a perfect square here. So now we've got our perfect square. We're going to take the square root on both sides, plus or minus. And here's the part why we kept this. If you have a square root with a fraction underneath it, you can split it up into 2 pieces. And what should always happen here is our denominator should be a perfect square. So if we do this, square root of 4 is 2. And what's going to happen then is we're going to have a common denominator already with what's on the other side of the equation. Then our last step is subtracting 9 halves on both sides. When we go to do that, what we're going to do, I'll rewrite it first this time. But what's going to happen is our denominator is going to be the same. So a more condensed way that I can write that, I can actually write that all as one fraction, like this. And I can say those are my exact answers. By those, I mean because there's a plus square root of 21 on the one part, and there's a minus square root of 21 on the other part. So those would be the exact answers. And then if we want to get approximate answers, what we can do is we can, well, let's start with the minus, I guess. We can type this in our calculator. What we need to make sure we do, though, is that whole numerator has to have parentheses around it, because the whole numerator needs to be divided by 2. If you don't put parentheses, then it's just going to take half of the square root of 21. So the whole numerator in parentheses, and then, like I said, if you want to just do, second enter, and then just change to subtraction to addition, and then we'll just get these to the nearest hundredth again. So this first one would come out as nearest hundredth negative 6 79 if we round that to the nearest hundredth. So the second one comes out as negative 2 21 Just depending on your calculator, with this square root part, if your calculator has a beginning parenthesis for the square root, you need an end parenthesis for the square root and then another end parenthesis to end your numerator out.